Hello, my dear friends, welcome back. If you remember last class, we talked about the basic proportionality theorem, or basically known as the Thales theorem, from this chapter of similar triangles, class 10 mathematics. And we have also seen what are similar triangles, what are the properties they hold, when can two triangles be said to be similar, and if two triangles are similar, then what are the properties it holds again, that the corresponding angles are equal, the corresponding sides are in the same ratio. So if you are still confused what are similar triangles, you can kindly go through those videos. Here today in this video, we will be discussing another very important theorem of similar triangles. What happens to the areas of two similar triangles? Okay, so we'll just focus on this particular theorem only for this video. Now, as the theorem states, it states that the ratio of the areas of two similar triangles, that means we already have two triangles which are similar. So the ratios of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. So what it means is, okay, let's first write down what is given. What is given is we have two similar triangles, triangle ABC and let's say triangle DEF. You can name in your own ways the triangle. Okay, so what we are supposed to be proving is, or what proof do we have from this theorem, is that the ratio of the areas of two similar triangles, that means area of triangle ABC upon area of triangle DEF will be equal to the ratio of the squares of their corresponding sides. That means if we start with the triangle ABC, then it's AB square by its corresponding sides. DE square will be also equal to AC square by DF square is equal to BC square by EF square. This is what the theorem states, and we will be proving this. So normally for NBSC, Nagaland Board of School Education, these theorems are usually asked, okay, for the exam. So somehow it is important also. Now construction, what we will do is we will let us draw AM perpendicular to BC and DN perpendicular to EF. Okay, we will need this. Now for the proof, before we begin for the proof, it is already given that since triangle ABC is similar to triangle DEF, right, triangle ABC is similar to triangle DEF, so therefore if two triangles are similar, what were the properties? What we will have is angle A, the corresponding angles, after we arrange the angles, the triangles, angle A would be equal to angle D, angle B would be equal to angle E, angle C would be equal to angle F. And what more? Their corresponding sides will also be in the same ratio, that is AB by DE would be equal to AC by DF would be equal to BC by EF. Okay, all right, so these are some properties which we already have from what is given, because it is given that these two triangles are similar. Okay, now let's try to get the proof. Now if we consider triangle ABM and triangle DEN, these two triangles, what can we have? Let's have a look. So I'll just draw the required triangle only. Okay, that is, it's always good to have your specific triangles roughly, so that there is no confusion. DEF. Okay, this is what we have. So from the main figure we see that angle B is equal to angle E. So this is already equal. Okay, so let's see what we can do. In triangles ABM and DEN, what we have is angle B is equal to angle E. This is actually already let's say given from the main equation. Angle, this was M and this was, sorry, not FN, okay, as for the figure, and angle AMB is equal to angle DNE. Why is that? Because of the construction. By construction, both angles are 90 degrees. So therefore triangle ABM, isn't it similar to triangle DEN? Because just to prove that two triangles are similar, if we can prove that two corresponding angles are equal, then and that is enough, because by angle similarity criterion. So now if these two triangles are similar, what will happen? If these two triangles are similar, since we're dealing with sides now, their sides will be, corresponding sides will be in the same ratio, divided by AM upon DN, which if we want to continue, even BM would be equal to EN. But this part is actually not needed for us, but anyway, some of you may think that why is this not mentioned, you know? So let me just mention, and what is needed, we will just use that only. Now if you look at from equation 1 and 2, we have, see, what was our equation 1? Our equation 1 was, let me just keep it here. Our equation 1 was AB by DE, see, AB by DE, which is in equation 2 also, is equal to AC by DF is equal to BC by EF. Now AB by DE, AB by DE is equal to AC by DF, BC by EF is also equal to AM by DN. We can do that, isn't it? Because this ratio is equal to AM by DN, and this particular ratio is also equal to the remaining other two ratios also. So in that case, 1, 2, 3, 4, 5, all these ratios will be equal. Actually even this also, but this one, as I mentioned, this is actually not needed for our proof, so that's why we will just ignore this part. Okay, so this is what we have. So we can use this as equation 3. So far this is the result that we get. Now we need to bring in area. So now what we will do is we'll bring in the area formula, that is area of triangle ABC divided by area of triangle DEF. So if you remember, what was the formula for area of a triangle? That is, okay, I'll just write here, half into base into height. Here also half into base into height. So half into base and height. We need to discuss on the base and height. If you look at the figure, if you look at this figure, height for this triangle is AM. So the base, if AM is the height, so this height stands on this side, BC. So the base becomes BC. And for this triangle, DN is the height, so the base becomes EF. So half we can cancel, no problem with that. So we are left with BC by EF into AM by DN. Now have a look at the question 3. AM by DN. Can we not write it as again BC by EF, because they are all same? So that means BC by EF into, instead of AM by DN, can we write BC by EF? Let's say using 3. Then that becomes BC square by EF square. Right. Okay. Now what we have is, have a look here, I'll just continue here. But we also have that AB by DE is equal to BC by EF is equal to AC by DF. This was from equation 1. Now BC square by EF square. So square of course won't change the ratio, I mean the equality. So what will happen is BC square by EF square will also be equal to AB square by DE square will be equal to AC square by DF square, isn't it? Right, because if two ratios are equal, then squaring them also will result in the same ratio. The ratios will still be equal, right? So therefore, in this conclusion, what we can have is, therefore, area of triangle ABC by area of triangle DEF would be equal to what? Is actually equal to BC square by EF square. Now BC square by EF square is also equal to AB square by DE square, which is also equal to AC square by DF square. So hence proved. So this is our proof to the theorem, which states that if we have two triangles which are similar, then the ratio of their areas would be also equal to the squares of their corresponding sides. That means if you have two triangles ABC, DEF, then the ratio of the triangles, area of triangle ABC and DEF would be equal to squares of their corresponding sides. That is, AC square by DF square is equal to BC square by EF square. So this is what the theorem gave us, and we have proved it also without any problem. Okay, all right, then I hope you have liked this video. Please study this theorem, and this is also a very important theorem. All right, so if you have liked, kindly please do like the video, subscribe and share too. Okay, thank you. I'll see you in the next video with the next theorem, that will be Pythagoras theorem. Okay, bye bye.